We are meeting after a weekend. So let me tell you, we finished some of the layer 2 topics. Okay. Theory was already taken for DHCP, spoofing, IP spoofing, ARP spoofing. These are some of the attacks, common attacks, and I explained you how this attack take place and how to mitigate those attacks. And then we did practically also. I showed you how DHCP spoofing works and how DHCP snooping works. Both, one is attack, one is mitigation of that attack. Then we did port security. Now port security is basically configured on access layer switches, where my switch learns the MAC address and authorize the user. But the problem here is port security that much secure? Then the answer is no, because hackers can easily spoof MAC address also. There are tools available which can spoof the MAC address. That means whatever source MAC address the frame carries. You all must be aware that layer 2 frames carry source MAC address, destination MAC address, hardware address, hexadecimal address. You all must be aware that hexadecimal address is A2. Can anyone tell me what is that? Hexadecimal addressing. A to Z or A2? Hello? A2, A2F. Sure. 0 to 9, and then A, B, C, D, E. So A is 10, B is 11, C is 12, 13, 14, and then F is what? 15. So 0 to 15 is 16 digit, right? Hexadecimal. 48 bit or 6 bytes is the size of that MAC address. So we saw how port security works practically also and theoretical also. Okay. I explained you what is the advantage of having port security on switches. Now we will be doing other layer 2 attacks like STP attacks. What is STP? STP means spanning tree protocol. Earlier we used to have layer 2 switching loops. In order to avoid layer 2 switching loop, they came out with spanning tree protocol. Cisco used to have, or Cisco is having his own proprietary protocol PVST plus, per VLAN spanning tree plus, and then RPVST plus, an open standard MSTP. Now all these stuff you guys must have studied in CCNA routing switching or enterprise. So today we are not going to discuss how STP work. We are going to see how we are going to protect our STP on switches, or how we are going to protect those STP attacks. Here the ultimate goal of a hacker is to disturb the LAN working, and for that reason we have certain guards being designed in this STP, that is BPDU guard, root guard, BPDU filter. When we talk about port fast, an end user workstation is usually connected to a switch port in the access layer. If the workstation is powered on and then turned on, the switch will sense that there is a port link status has gone down and back up. The port will not be in an unusable state until STP cycle. So, in STP you have some states, okay, like listening, learning, forwarding, disable state, okay, block state. So, initially when the port comes up on a switch immediately goes in a cycle, STP cycle. That means the port earlier is now in blocking mode and it is going towards forwarding state because somebody connected. So, with the default STP timers, the port moves into listening state, and from listening to learning it is 15 seconds, and then from learning to forwarding it is 15 seconds. In short, whenever you connect any device, any LAN device, might be IP phone, might be a PC, might be a printer, laptop, anything, any device you connect physically, your STP is going to go through a cycle, and STP is going to make you wait for 30 seconds. Now, initially it is a good practice basically, like when you go to airport, suppose you are flying to some international country, some country from your country. So, when you fly, you have to do, or you have to carry out some formalities on airport. You have to do some verification, passport, visa, immigration check, and in that the very important one is the security. So, when it comes to security, the security will always check your baggages, scan your baggages. They will frisk you for any sharp weapons or anything, and there are some restrictions. You can't carry scissor, you can't carry knife, battery chargers or some extra charges, whatever. So, all those things they will check. So, when you go on airport, you see there are two queues, one is for ladies, one is for gents. So, now you are going with your family for a vacation and you are carrying a baby of say 8 months or 6 months baby. You can see people carrying their babies also. Now, when somebody tells you that you have to go for a security check, you agree, because you are not a criminal or you are not a terrorist. You are a good person. You are a God fearing person. You are a respected citizen. So, you always go for a security check. Then your wife also goes for a security check. Now, imagine the security guard is telling you that you have to scan your baby also, put it in the tray. 5 months baby, you are keeping in the tray and putting it into the scanner. You will kill that security. So, such a small baby, how can you check such a small baby? It is not going to do any attack. So, you see, they do not check for small babies until unless you are wrapping that baby with multiple clothes and all, just in case if you are hiding something under the clothes. So, they might check, but otherwise they do not check. At least what I know, they do not check. Why? Because the mentality of the parents and other government officials says that there is no threat from babies. Breastfeeding babies are there. So, why to check them for all those sharp weapons or metal? They avoid, they leave them, otherwise everybody is checked. So, this is just an example where I am trying to tell you that PCs are not going to create any loop, but yes, if you connect a switch, if you connect any device other than PC, there is a chance that they might create a loop, layer 2 loop. So, what is the motto here? The requirement here is STP is doing his job and you want STP to bypass this checking of PC, and for that reason what they are doing, what you are doing as an administrator, you are configuring one feature called port fast. In simple terms, I am telling my switch that boss, whenever I connect a PC, please don't go for all those STP cycles of listening to learning and learning to forwarding and waste my 30 seconds, because see, when you connect the PC, you can't bring it up unless 30 seconds is there. You have to wait for 30 seconds for connectivity, because you see, when you connect, it is amber, the light is amber and then it will green after 30 seconds. So, it is, so you want to bypass this, you want to tell STP that these ports are not going to create any switching loop. So, when you configure port fast, when your switch is by default configured for PVST plus or rapid spanning tree protocol, you configure port fast to bring this feature where you want the switch to come up immediately, switch port should come up immediately when you connect the PC. Okay. So, port fast is a very easy feature, everybody try to do that. Okay. Spanning tree port fast is the command. You can do globally also, you can do interface based also. You can go on the interface and say interface range gig 0 by 1 to whatever 20 ports, configure them as what? Port fast. Remember that port fast to be configured strictly only on access ports, not on trunk ports. Otherwise, you will be having a loop if you misconfigure this feature. So, you have to be very careful, like you are doing port fast only on those ports which are access layer ports, where you are 100% sure you are going to get or you are going to connect PCs only. Now, the problem is, in case if somebody by mistake or purposely connect a PC on these ports which are configured for port fast, what will happen? You will be having a layer 2 switching loop. Spanning tree is not disabled on these ports when you configure port fast. Okay. So, I do not want by chance anything to happen. It can be purposely, somebody might be doing it purposely to create a loop or by mistake. Like for example, You see we have 3-pin holder socket, and this holds 25 years back, 30 years back, these holes were open holes. So, I remember many of the kids, like who are very young, they used to put their fingers inside this and they used to get electrocuted, shock. Many died also because of that. Only option was parents have to be, they should know what their child is doing, where he is going, what he is doing. But later on you see parents started working, mom is also working, dad is also working. So, there is no time to look at the kids playing sessions, how he is moving in home, what he is doing, whether he is safe or not. So, later on I notice, you all must have noticed that there is now a protector in front of this hole inside. So, when you try to plug in, try to put any holder or anything, you will see that flap goes up, and when you remove it, the flap comes in. So, if I put a finger also, my finger won't go and touch the circuit, and if the finger don't go and touch the circuit, there are no chances of getting electrocuted, especially to the kids. Adult won't do that because they know if I touch a live wire or I put finger there or put some nail there. Many times they used to put some nail also, like when a kid got the nail, so he go and he just go there and put that nail. So, what is that? The term for that is guard. There is a guard there. You see many gadgets, you will get a guard, especially those gadgets which are dangerous, you get a guard. Like nowadays you are very cautious about your mobile phones, so you put a guard also, scratch guard, screen guard, mobile cover. You are very cautious about your valuables. So, BPDU guard is a feature actually developed to protect the integrity of the switch ports where you have configured port fast or where you have enabled port fast. So, whenever I have configured port fast, I also configure BPDU guard. Why? Because in worst case, suppose somebody do or by mistake or purposely connect a switch where port fast is connected, what will happen? There will be a layer 2 switching loop. So, in order to avoid that, we have to configure BPDU guard. Again, BPDU guard is also access layer feature. Why? Because see, you are configuring port fast on access layer. So, you are configuring BPDU guard also there. Okay. Now, in worst case, suppose you have configured BPDU guard, wherever you have configured port fast. I told you port fast can be configured in two methods. One is globally and one is interface based. So, if you have configured your port fast globally, then you apply your BPDU guard also globally. So, you say spanning tree port fast BPDU guard default. So, now it is active on all the access ports, all the access. So, whenever you configure access port, not trunk port, whenever you configure access port, switch port mode access, switch port access VLAN 10, and whenever you configure port fast, automatically the BPDU guard is active with this command, spanning tree port fast BPDU guard default. Suppose second method is you have given a range, interface range. So, in that case you can go on with the same command, interface range and spanning tree BPDU guard enable. So now suppose you have a switch where you have lot of PCs, or forget it, PCs, you don't have PCs, you just configure port fast on access ports, and then you also configure BPDU guard. So what happen in case somebody connects a switch here? There is a strict warning given during the configuration of port fast that don't connect hubs, switches, any device that is, or that device possibly can form a loop, especially a switch. Don't connect a switch on those ports, because 100% he is going to send some BPDUs, bridge protocol data unit. BPDU means what? Bridge protocol data units, something like, it is a configuration, it is the information about the switch. Lot of stuff are there in that BPDU configuration. BPDU, bridge protocol data units. A switch might receive this BPDU and can form a loop, but in case of PC won't give BPDUs. PC don't understand what is BPDUs, PC don't understand what is VLAN. So PC won't give any BPDUs. So if PC is not giving BPDUs, that means it's not creating loop. So in worst case, suppose if someone connects by mistake or purposely a switch, what will happen? He will immediately give a BPDU. So what this guard will do? He is being clearly told that we are not expecting any BPDUs on these ports, because these are all access port to be connected to PCs. But as soon as he receives BPDU, what he will do? He will immediately put that port into error disable. See, if you remember earlier I showed you, when you do port security, due to P secure violation, your port might go into what? Error disable. So same way, if you configure BPDU guard, due to BPDUs, these ports will go into error disable state. So error disable is a common state where the port is already shut down for some error conditions. So error disable is not just, this situation never comes only for one reason. If you do port security and if there is a violation, it will shut down in error disable state. If you do BPDU guard and if he receives any BPDU on that port, immediately it will shut down into error state. Clear, guys? What is port fast? What is BPDU guard? See, these are all part of switching, but you know we are doing what? Security. So it is not just we have to do security at L3 level, we have to do security at L2 level also. So you should know these terms. You should know what is the meaning of BPDU guard, what is the meaning of BPDU filter, what is the meaning of root guard, what is the meaning of port fast, all those stuff you should know. So clear? Though it is very easy, those who have done their CCNA and CCNP switching knows about this. But in CCNP security, this is being discussed in a different angle. Here we are more focused on security. In CCNP switching or in CCNP modules, they are trying to be more focused on VLANs, they are not on security. But yes, the topics were there earlier. Now I don't know whether these topics are there or not. So let me show you this practical, but first we will finish root guard also and BPDU filter. Now what is root guard? Root guard is something where I want my, because in STP there is a concept of electing one root bridge. STP is a very strong, robust protocol already inbuilt by Cisco on all the switches, and not only Cisco, non-Cisco who manufactures switches sorry, also will also have spanning tree protocol in their switches. They might have rapid spanning tree, they might have MSTP, or they might have IEEE, but now IEEE open standard protocols are outdated. Nobody go for that because the convergence is very slow. You can't wait for that 30-second or 50-second for the convergence, because in a big environment or big setup it is necessary that your convergence should be faster. So when you want the convergence should be faster, you don't go with the old protocols. So here you see we are not using STP old protocol, like PVST is also gone. Instead of PVST we have PVST plus, because PVST was not compatible with other vendor switch protocols. Cisco is having per VLAN spanning tree plus protocol. Then they came out with RPVST plus protocol, rapid. So definitely non-Cisco vendors or non-Cisco guys who are manufacturing switches also follow this protocol. It is not just Cisco proprietary. So in STP there is a concept of electing one root bridge and others as non-root bridge. Simple funda, like I want to avoid the loop in this topology, in this network, and to avoid this loop I want spanning tree to work smoothly on these switches, and for that spanning tree needs the first 50 seconds. The conversion time of spanning tree is what? 50 seconds, 50. In that he elects the root bridge and rest as a non-root bridge. The traffic always flows from the root bridge. Only root bridges are allowed to send the traffic towards non-root bridge on root port. Root bridge don't carry any root port. It is the non-root bridges who carry root port. So initially what happened, there is a root bridge election take place, there is a root port election take place, there is a designated port election take place, it's a block port election take place. So what are the different terms are there? There is a term called root bridge, there is a term called root port, there is a term called designated port, there is a term called block port, there is a term called non-root bridge. So after 50 seconds, you see the 50 second is the conversion time. You see after 50 seconds STP is converged, and you will see what these ports, root port, designated port, block port, root bridge, non-root bridge, this kind of terminology is there. Now like it's a simple example, man. Once your prime minister or president is elected with majority and then he start working. So in India we have a 5 years of tenure, 5 years my prime minister, we have prime ministers here. So 5 years he is going to work for the country, he is going to prove his capability, how he is running the country and all those stuff, and after 5 years there will be re-elections, and if he got selected again then he will run another 5 years. This is the general process, but for some reason he is being elected, and after 1 month, 2 months, 3 months or 1 year, somebody says, no, we don't like this Prime Minister, he is not working up to the mark, he is making the country worse, change it. No, that is not possible. There is some locking period, there is some rule, regulation. Until unless he dies, that is a different story. But there is some locking periods, there is some policies that country have to follow. You cannot just go on telling, no, we don't like this Prime Minister, change him within 1 year or within 1 month. You have to give him a time of 5 years. So, same way, if anything goes wrong in a country for short time, like change of Prime Minister in short period without completing that 5 years, there is a chance that the share market, there is a chance that all these progress get halted. So, that is why there is a locking period. So, when I tell you that STP is already converged with a root bridge, root port, designated port, block port, and in worst case, suppose this topology changes. Topology changes means a new root bridge comes in. Like for example, you are telling me that X is the Prime Minister of country, and suddenly a Y comes and say, I am better than this guy, come on, appoint me. No, not possible. When my X is my Prime Minister, I cannot immediately appoint Y or do re-election to make him work for the next month or next year. No, not possible. There is some locking period. So, I want to maintain that stability in the network. I want to maintain a loop free environment in the switch network, and for that reason I am going to elect one root bridge, and once the root bridge is elected on a criteria. What is that criteria? Can anyone tell me? See guys, I want active participation. I know you guys are very intelligent. Okay, so speak up means message me, otherwise I will feel you guys are sleeping. Bridge ID. What is bridge ID? Is comprised of what? Bridge ID is nothing but it carries the priority value and lowest MAC address. MAC address, yes. So, it is a combination of priority and MAC address. So, for electing a root bridge, the priority should be less. Remember, in switching lower is the best, in routing higher is the best. In switching lower is the best, in routing higher is the best. Like for example, if you are running a marathon, people say come first. Nobody will say come 10th position or 100th position. People say come first. In school I remember, everybody say come on, come first. But in studies, everybody wants higher. Higher is the best. What is your percentage? 80, 90, whatever. Higher is the best. So, same way in switching lower is the best, and in this case lowest bridge ID will be taken into consideration. So, if the guy is having a priority of say 4096, remember the priority value from in the multiples of 0, 4096, 8192, 16384, 32,768 or something like that, and then 65,536. So, always my priority is in the multiples of 4096, and the default priority, what is the default priority? Anyone tell me on the switches, what is the default priority? Very good. First, 32,768 is the default priority of a switch. So, in case if all the switch carries this 786, okay, good, Faizan, okay. So 32,768, okay, plus if it is for VLAN 1, then 769, okay. Always it is in the multiples of 4096. So 16,384 and 16,384 comes to how much, guys? 8, 6, 7 and 3, 32,768 plus 1, okay, not 789 for VLAN 1. How can it be 789? Always VLAN ID plus whatever. Now the question is, in case of tie, lowest MAC address will be taken into consideration. So let us see that one of my switch, let us say one of my switch, say switch 1, which is carrying a priority of 4096, becomes the root bridge, and for some reason one more switch joins with a priority of 0. What will happen? He will become root bridge. Earlier my switch was 4096 because of the priority, because these guys carry 32,768, this guy also carries 32,768, and for some reason there is a switch 4 joins with a priority of 0. What will happen? Immediately he will be considered as what? Root bridge, and the whole setup might go in a loop, because see, I told you, no, if my prime minister is being elected, he will continue for next 5 years, and for some reason he dies or for some other political bylaws he is being changed. What will happen? There will be definitely some kind of problem occurs, like people started discussing, news channel also bombarding with that news, share market crashes, and many things happen in the country in the background. So it is not easy to change a prime minister or a president immediately. It is to be done very safely, or it is to be not to be done until the time comes. So same way, for this reason what I am going to do, I am going to place root guard, because I do not want my setup to get disturbed for these reasons, and that is why I am going to configure root guard. The root guard feature can be enabled on all switches, all switch ports, because see you are asking me, sir, where I am going to apply root guard or where I am going to apply BPDU guard. So BPDU guard is okay, wherever you apply port first you can go and apply BPDU guard, but what about root guard? So the question is, if I am applying root guard, that means I should see there should be, there shouldn't be an entry of a new switch from that area. So initially the best practice, as per some of the best authors, the best practice as per the industry, this thing working, switches to be introduced on distribution layer, okay, distribution layer. So for that reason you can configure this feature root guard anywhere or on all switch port in the network, okay, the port, but remember, do not configure it on the root port. It should not be a root port, okay. So okay, I have placed my root guard, I have configured my root guard. and for some reason if a new switch is introduced with a priority of 0, my existing priority is 4096, that is for 4096, and for some reason a new switch is introduced in the network with a priority of 0. What will happen? The new switch will become the root bridge, and I don't want this. So, what will happen when I place root guard? Root guard is going to place this port in root inconsistent state. Now, there are different meaning. Error disable state is different. I told you one example where I was out of town, my apartment was locked, and for some reason there was a power tripper going down and the whole power of my apartment was gone. So, when I came, I was happy that my apartment is safe from fire. What was the reason? Because of that tripper, circuit breaker. But later on I was unhappy because I lost my cheese, butter, everything, because my refrigerator also went off and all the material inside the refrigerator has gone bad. So, what is I am trying to tell you that I want safety also, and at the same time I don't want my things should be lost, or I don't want something bad happens to me in any form. So, for that reason, if I am doing root guard, what will happen? My port remains up. My port remains up, but that port is placed into root inconsistent state. Now, you must be wondering what is the difference between error disable state and root inconsistent state. See, error disable means complete shutdown of that port for error condition, but root inconsistent state is not that. In root inconsistent state, the port is up, port is receiving BPDUs, port can see those BPDUs coming in from the new switch. So, what that port is going to be? He won't accept any data frames. Always remember, when it comes to when the port is in listening state, he is not supposed to send the data frames, but if the port is in forwarding state, he can send those data frames, and it is important. Data frames are more important, man. So, data frames are not allowed, so that switch, if is connected with many users, that those users will be restricted in the LAN and they won't be able to communicate with the server. This is root inconsistent state. Ports are allowed to remain up, but the port is in the root, no user data is sent across it. That means that switch is indirectly out of the network. He is not supposed to send any data packet. Why? The only reason is he is carrying a better priority, and his better priority can lead to a layer 2 switching loop, because already my root bridge is elected with a priority of 4096, and I don't want one more switch to come in and change the whole environment, and that is why I place root guard. Very important feature. Clear, guys? What is the meaning of root guard and what is the meaning of root inconsistent state? Now, what will happen? How you are going to remove this state? Simple. You are going to change the priority of the new switch. Like many times you see some kids, they know the pronunciation of some of the words are wrong. Teacher always shout, don't say like this, say like this. So he is continuously repeating the wrong sentence or wrong word. So she will, in fact she might beat also to that boy or a girl, but later on the boy or a girl will understand what is his mistake and the mistake is rectified. Once the mistake is rectified, everything is normal. So when it comes to irreducible state, and if the priority of the new switch is changed to 32,768, which is more than 4096, the inconsistent state is lifted. It's like a ban. It's like a ban. So anytime if you do things in a proper order, the ban is lifted. Otherwise you are banned. So in security, remember, though we are talking about layer 2 security, these are all just to protect spanning tree features, because here the hacker might try to manipulate those spanning tree features and harm the whole LAN, because you know everyone knows that switches are considered as a centralized device in a star topology. In networking, we are following star topology. We have a LAN device like switch who is considered as a centralized device. All the PCs, all the routers, all the switches, all the equipments, printer, IP phone, everything connects to the switch, centralized device. So it becomes important for you to protect those switches from these kind of attacks. Otherwise your whole LAN will be down. Forget about router. Internally you have to keep your network safe and loop free. Loop is always bad. Nah? Loop is not good. Loop can choke the network. Loop can leads to denial of service attack, DOS attack, or DDoS attack, distributed denial of service attack, or embryonic attack. Embryonic means what? Have you heard about embryonic? Embryo means what? Have you seen an egg, and from that egg you see a chicken is coming out, half open. The chicken is trying to come up, baby chicken from the egg. Half is inside the egg, half is trying to come up. This is also, the term embryo has come from this. Embryonic attack means half open connections. Simple na, if I tell you just give me a break of 2 minutes. So what you will do? You will run away or what? No, you will wait. Sir is coming after 2 minutes. Now what happen if I don't come till 30 minutes, 40 minutes, 50? You will be say, okay, let's wait for more time, because the session is say from 5 to 7. So sir said 2 minutes. So we will wait, and after 1 or 2 hours you will quit, because there is no sign, there is no activity, there is no voice, nothing. So half open connections are like, making the server wait. Like you have studied TCP, transmission control protocol, 3-way handshake. Sync packet goes, acknowledgement and sync comes. Hacker is not sending the acknowledgement. So server is waiting, man. If I am telling you I am coming in 2 minutes, you are all waiting. So this is an attack. I wasted your time. Some people are really, tired after a job. Some want to go home. Some are hungry. Some want to go and meet their girlfriends. And then you are waiting. DOS attack ho gaya bhai. It's a DOS attack. Denial of service. Legitimate users are not served. So core switches and access switches, each interface you have to see. I told you once again. If you are following Cisco hierarchy says First comes the core layer, second comes the distribution layer, third comes the access layer. In switching, okay, nowadays we have changed, we have follow, what is the new technology of following? SD access, VXLAN. In that, what we do? We have a root and leaf, and you have a root, or you can say spine and leaf. But at least still some of the major networks, they follow hierarchy. Some people go for collapse core, distribution and core under one thing. So as a security administrator, as a network administrator, guys, if you are introducing a switch in the network, normally you should do it from the distribution layer. So always you should configure the guards on near the uplinks, or like you are asking me, sir, where to place the security guard? Definitely near the gate. Okay. So it depends how you build your network, how you design your network accordingly. Because see, security, if you don't place, like for example, I will place my security guard on terrace. My building security guard goes and sit on the terrace. Why? For a better view, I can see from top terrace. Everybody can, everyone who is coming to my building. But in worst case, suppose some attack happens, terrace se bhag ke jayega kya wo niche? He won't go running from terrace. That is why we place the security exactly near the gate. So if you don't do security configuration at the right place, it is going to be fail. You are attracting these vulnerabilities. You have seen lot of movies when they are robbing a bank. They always check for the CCTV cameras, they always check for the security guard, they always check for the alarm buttons. Which time people are less, which time, everything is taken into consideration. So placement of guard is very important. Clear, guys? So yes, you can do it. See, they are telling you root guard can be enabled on all switch ports in the network. Okay, the port on each switch that is considered to be closest to the root bridge, that is ports in the network of which the root bridge should not appear. That means don't do it on root port, because if you do it on root port, what will happen? Your BPDUs will be suppressed and you won't be getting the configuration. Clear? So I explained you BPDU guard, bridge protocol data units guard. I explained you root guard. What was next? BPDU filter. Have you heard about BPDU filter? Loop guard is basically, I'll tell you. This is my root bridge. Okay. This is my root port of switch 2. This is my root port of switch 2. Always remember, root port is there on non-root bridges, not on root. This guy is having all designated ports, and this is a block port. Suppose I configure loop guard here. Why? Because what happens, if my root port goes down for some reason, genuine reason, either the port is faulty, cable is faulty, my root bridge will immediately send a message to switch 2 that there is some issue with my port going towards switch 2. Immediate BPDU comes in. This BPDU is forwarded to switch 2 or switch 3 via switch 2. What happened? My root port has gone down, switch 3 root port goes down, switch 1 immediately comes to know about this issue and he immediately sends a BPDU. This BPDU is forwarded on all designated port. Here also, here also, here. Now what switch 3 will do, instead of waiting for that 20 second, what is that 20 second? There are total 50 second. 15 plus 15. This is the timeout, basically idle timeout. After this only it start putting the port into listening, learning and forwarding. Listening to learning 15 second, learning to forwarding 15 second. It is an STP state, or you can say timer, STP timer. You have hello timer, okay. There are many timers in STP also. So in worst case, suppose he start bringing this port up, it will take 30 seconds, sorry, not minutes, 30 seconds. This is a genuine working. So in case my root port goes down, switch 1 immediately responds to give response to switch 2 forward this on designated port. So this guy is listening on the block port. So what he will do, he will immediately put that port into listening, learning and forwarding, thinking that this information is received by my root bridge. Now this is a normal working, and for some reason say this port has misbehaved. So what will happen? This guy will inform him that boss, there is some issue with this switch 2, why you are keeping your port block? Because there is already a guy, switch 2 is facing issue with the root port. So he will have a new root port here, but if he has a new root port here, that means you have to make it what? Designated. Okay, you have to you already have a root port here, perfect, but this guy is having some issue. So what will happen now? He will bring this port into designated. Earlier he was blocked. Now the question is, there is no, there is a reason in fiber. In fiber, there is sometimes receiving or transmitting part is error, might be fiber bend or something. So Cisco has come out with a feature called UDLD, unidirectional link detection. Remember, Cisco proprietary protocol to monitor the uplinks or trunk links, fiber links specially, because in fiber what happens, either transmission or receiving is error, but the link is up. In normal Cat5 cables, if the wire is not, it's gone bad, then the light is gone. If the port is gone, the light is gone. But in fiber, there is a chance that though it is having issues, errors, it will show up. So I don't want corrupt frames, I don't want error frames to come in, and for that reason what I will do, I will go for UDLD feature. So here I have activated UDLD feature. So UDLD feature will give me the exact update, what is the issue, and if I configure loop guard here, my loop guard is going to hold this port not to become designated, because there might be some minor error, and for worst case if this root port is still up with minor error, and in case if this fellow also become designated, this fellow also become designated, this fellow becomes root port, this fellow is so what will happen, all the links are up now and there will be a loop, and for that reason I configure loop guard along with UDLT. So, if there is a genuine reason, it will make designated. If there is some kind of error reason, it will hold this port into block state and he will not allow him to become what? Designated. This is the feature of loop guard. Loop guard. Clear? Bakery, clear? Loop guard. You cannot see this practical here, not possible, because I cannot emulate the error frames on root port, because it will not work. Okay, clear guys? So, now let us go for BPDU filter, the last feature of protecting against STP attacks. BPDU filter means what? Now, this is my switch, wait, I will show you with the diagram. See, this is designated port of this guy, this is a root bridge, huh? This is also designated, 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 this is also designated. So, you see my switch 2 receives BPDU from root port, this is his root port. Huh? So, what he will do now? As soon as switch 2 receives fresh BPDU, he will forward it on all the designated port. Right? What is the default behavior? Whenever I receive a BPDU on my root port, I am going to forward it on all the other switch ports which are as per STP tag, they are all designated. Now, it is very okay, it is very important that this BPDUs be forwarded to switch 5, okay, good. Switch 3 also, very good. No doubt switch 3 might have a block port, but anyway, his job, switch 2 job is whenever I receive a BPDU, I am going to forward it on designated port. But see, this 3 device is a PC. PCs don't understand I told you PCs don't understand BPDU. If I go to a tea stall, tea stall, and if I give a lecture on networking or security, what do you think? They will be happy or what? What they will say? They will say this guy has gone mad, he is coming and telling all those stuff. We are not interested. We don't understand the word, what is he trying to explain. Security or routing switching, tea wala, the one who sells tea. So when you go to drink tea, you won't discuss networking with that guy. You will discuss how you made this tea, is it sugar, without sugar, all those stuff. And this guy is very interested in this. Oh yes, he will explain you, I added milk, I added ginger and blah blah. He won't discuss about security or networking. So why you are wasting your energy and time explaining him networking and security when he don't understand, boss? So if I am receiving a BPDU, I am sending it to PC who don't understand BPDU, then why he is wasting his resources forwarding those BPDUs to those PC? You can configure BPDU filter on those ports. So when you configure BPDU filter on these ports where PCs are configured, spanning tree get disabled and there is no BPDU being forwarded on these ports. So you are saving the resources of your switch because he is trying to send unnecessary BPDUs on designated port. Like for example, if you have heard about passive interface in CCNA, EIGRP protocol not sending hello messages on ports facing towards LAN or PCs. So here you are going to apply BPDU filter. See, BPDU guard is different, root guard is different, loop guard is different, and filter is different. Clear? So when we talk about this, always remember, first you understand the theory. If I jump to practical, you won't understand. And I know many of them are freshers, not even studied their CCNA. They don't know what is switching. So there is a chance that they will get confused if I show them directly practical without explaining the feature. Clear? So we will take a break of 5 minutes and then I will show you the practical for all those stuff which we discussed just now, like how the port was being configured, how the things work, how BPDU guard works, how root guard works, how BPDU filter work. I can show you practical for all these topics. Okay? So just wait for 5 minutes, I will join you back. Thank you. Hello, I am back. I am sharing my screen. If I go to switch 1, and say show spanning tree. You can see the priority value of this switch is 32,769 and all the ports are in designated. And he is telling also this bridge is the root. That means he has become root bridge on the basis of bridge ID, and bridge ID is comprised of priority and MAC address. Okay. Now, if I go on switch 2 and say show spanning tree, he is telling my root bridge is one who is reachable via, can you see here there is a root port here. So, E0 by 1, see this one is the root port for this guy, and this fellow is a root bridge. Okay. All these PCs, when they start switch to, I will say debug spanning tree events. Debug spanning tree BPDU. See, there is the word transmit, transmits, transmit. So, when I say show, when I say debug spanning tree events, or if I say events. So, you see all the ports which are connected to PC, E0 by 0 is root, but what about E0 by 3? See, E0 by 3 is block, it should not be block, it is a PC. See, it is in forwarding E0 by 3 which is connected to PC. E0 by 1 is also connected to PC, forwarding. E1 by 3 is also forwarding. So, you see all the ports which are connected to PCs, PC1, PC2, they are all in forwarding state. So, if I shut down this port E0 by 3, I say shut, and then if I say no shut, you see it has gone into forwarding, because there is a chance that port fast is pre-configured. See, but if I do not configure port fast, if I say default interface E0 by 3, or if I say default interface E1 by 2, and for some reason if I shut down this port and then bring it up, you see it is going to go into listening state first. What time? 13:10:05. So, at 13:10:35 you will see the port will come up after spending 15 seconds in listening to learning and then learning to forwarding, see 5 and 15 is 20 seconds, and then when you see forwarding it will be like 30 seconds total time. So, this is the beauty of 35 seconds. Can you see? This is the beauty of port fast, that when you enable spanning tree, port fast, default or edge, and when I shut down this port now, and when I say no shut this port now, you will see it has gone into forwarding, from blocking immediately to forwarding. So, because of port fast, okay, can you see the screen now? Okay. Once again I show you the practical. I configure debug spanning tree events. If I go here and say interface E0 by 3, first I will make it default interface E0 by 3. Now I go to interface E0 by 3 and say shut, and then I say no shut. You can see the port has transitioned from blocking to listening after spending 15 seconds, that is 10, 13, 12, 10. Just see the seconds. After spending 15 seconds, see 25 he has come into learning state, and now after more 15 seconds, that is 40, it will go into forwarding. That means he is unnecessarily occupying, or he is unnecessarily off for 30 seconds because of STP cycle that take place on the switch, which is not allowing this port to come up immediately. So, in order to make it more faster, I am going to configure port fast, and when I say shut and then I say no shut, you see the port has jumped to forwarding immediately. Now, what I will do, I will also configure BPD guard here. So, whenever see whichever interface is configured for port fast and BPD guard, I took 0 by 3. So, what I will do, I will just save this configuration, show run interface E0 by 3. You see port fast, BPD guard, both are there. I saved it. Switch off this PC, stop this, delete this, and I connect switch here. Now, if I connect this on E0 by 3, first I start this, show spanning tree, show run interface G0 by 3, E0 by 3. So, if I go here on switch, so if I go here and say show spanning tree, you can see the priority is 32,000. So, I make it, I just change the priority. So, what is the command? Spanning tree VLAN 1 priority, I said 0. Show interface status. So, I change the priority of this switch, and when I see here on this switch 2, you can see it has gone into error disable state. BPD guard has placed this port into error disable state. Why? Because this guy or this particular switch was sending superior priority of 0, and just because I have applied a BPD guard on switch 2, he is not allowing this port to send superior BPD. So, what is I should do? I should go here on the switch and I should resolve this to 32,768. Now, you see, I go here on E0 by 3 shut and then no shut. Okay. I said shut, I said no shut. 61,440. So when I say show interface status, it should remove that error disable port. Why? Because now I am trying to send inferior BPDU from this R13. See what is my this thing, and E0 by 3 is my designated. So now he is telling, so I have to go here on E0 by 3 and say shut, and then I have to say what? No shut. Show interface status. Config T interface E0 by 3 shut, and then I have to say what? No shut. Possible that my MAC address is okay. Show spanning tree. I have to go to switch 1. Spanning tree VLAN 1 priority 0. So now my switch 3, that is R13. E0 by 3. Show spanning tree VLAN 1. I'm trying to find out who is my root bridge. So my switch 2 should allow this port. Show interface status. Still error. Show interface status. Normally when I configure BPDU on E0 by 3, BPDU guard, it always read the information that is coming in from E0 by 3. And if you see the show spanning tree of VLAN 1, it is 61,441. So we'll wait. I'll just shut down this port. Shut. And then I will do what? No shut. BPDU guard receive BPDU on port. Okay.
this is the feature we are doing for BPDU guard. So correct. So just because I have connected a switch and this switch is sending BPDU, he is not supposed to send BPDU on this port because this is an access port, he is rejecting. I will show you the practical next session about root guard, because I was mixing root guard with this. I changed the priority and I was thinking, so it is not root guard, it is just BPDU guard simple, where I should not receive any BPDU on port E0 by 3. If I receive BPDU on port E0 by 3, that means it will create a loop. So my BPDU guard will immediately put this port into error disable and he won't allow him to give the access. Clear? So tomorrow we'll do practical for BPDU filter. We'll do practical for, I will see if I can do it for loop guard also. I will show you. Okay. Then we'll go for private VLAN. Okay. I hope you understood the session. I hope you liked the session. Okay. Thank you. Bye. Take care.